Welcome back, everybody, and welcome back to the Inicus project. I'm excited to be back again and working on this project some more. As usual, we're continuing on with our current thing. We're making a custom MIDI controller for Bitamy, and I guess today we really have to keep working on the software. We did some really good work last time debouncing the potentiometer, but we probably need to do a little bit more there, and then we need to start figuring out how to make this work actually like a MIDI. And come to find out that there actually is an easier way to do this in the TNC libraries already. So that's what I'm going to be working on tonight. First, we're going to work on the potentiometer just a bit more, and then I'm going to start working on that. And I don't really have a great way to test it. I'll have to think on that one, because I got to figure out a program or something that lets me read the output from the MIDI. But anyways, so I'm going to be working some tonight. Feel free to hang out, chat, and talk about whatever. And let's just get this done. Let's get to work. I'll turn the music back on. And then I think our current goal there of write the hardware abstraction layer is probably pretty good. Hope everyone's having a good Tuesday. I'm doing all right myself. The weather's a lot nicer out now than it has been, the past few months. So it's actually warm out today and sunny out this late, and overall just seems a lot nicer outside. Okay, so let's see here. Last time this is the function we were writing, at least as part of it, to read the slider, and we were doing a lot here. You bet Elon isn't having a nice day. I don't know. It depends on what you. It depends on your definition of nice. Maybe they learned a lot. Maybe they learned a lot of really important stuff that's great later. Maybe somebody accidentally hit the detonate button and they didn't learn anything. So last time we did all this work to clean up this potentiometer, and it does, let me go ahead and compile this and upload it again. It does kind of work. There's just really a few instances where it seems to skip a little bit and get stuck going back and forth between two numbers. Here we go. So if I move this right now, we can see that once I stop moving it, it stays pretty still. It still moves a little bit though here and there. Moving, stop. Moving, stop. Moving, stop. Okay, pretty good. I think our algorithm works fairly well. So one last thing that I did learn is that MIDIs, when they're sending a volume value, or really any kind of variable value like that, send a number between 0 and 127. And obviously right here, we're sending a float value between 0 and 256. So something else that can help us here is actually that we need to get rid of the decimal, anything after the decimal place, as well as divide by 2. And I can't remember how modulus works with float values, so we're going to find out. But basically, to get to a number between 0 and 127, I can just do modulus 2. And I think that works with integers. I don't know if it works with floats because I honestly cannot remember. Types float into binary operator. Okay, yeah, that makes sense. Yep. So I have to convert it to an int. I'm sure there's a function in the math library for that. I just got to Google that real quick. Let's see. Arduino convert float to int. I don't want to just cast it. That doesn't seem right. But maybe that is a way you can do it. Oh, I guess it is. Okay. What's up, Ace? Haven't seen you around here in a while. Did you ever get that tarantula you were talking about? I realized the other day that I didn't ask about that. And I'm really interested to know the outcome of that story. You did? Oh, man. I don't want to see it. Like, I don't like spiders, but I'm glad you got it. Oh, you got multiple. That's cool. How many did you get? I guess I do just cast this to an int then, according to the... Alright, this is going to be weird. I think that'll work. Don't know the gender yet. Okay. Just one. Don't know the gender yet. Okay. Gotcha. Gotcha. I took that to mean that you had multiple, but... Expose them to radiation. Please don't. Oh, that's the last thing we need to do to 2021. All right. Okay, so what this does here, this is a float value. We've casted it to an integer and then did modulus 2. So it's going to divide by 2 with no remain. Is that how that works? Did I do that right? Should I have just used a division? I think I should have just used a division. That's just going to give us a number between 0 or either 0 or 1. But we'll try it anyway. Yep, there it is. Depending on if it's even or odd, it's giving us 0 or 1. All right. Back to computer programming basics. That should be a division. Okay, and then we'll upload that. Nothing about what you're doing. I'm doing a project for a friend here. We're making a custom sound mixing device because he likes to make music for his YouTube channel. And so right now it's just wires on a breadboard. Yeah, I got a little slide switch here that functions like the slider on a soundboard. And we're literally building one custom because those devices are pretty expensive. Music equipment's really expensive. And I think I can make it for just like $50 or $60 in parts. So, Dower code a few times in middle school. Yeah, I'm sure everybody has touched on it at some point. It was, as far as learning software, I didn't learn much until college when I had a classroom setting to force me to do it. And, hey, look, it works. Number between 0 and 127. Perfect. But I find it really hard to learn stuff like this unless you have a reason to. And now I'm better at it. Now I'm better at forcing myself to learn because I find it more interesting. But at the time when I first started coding, I didn't really understand like what you could do with it. And so it was hard to learn. But as soon as I was put in some classroom settings where I was given projects and I was like, oh, that's kind of cool. I can make this cool thing and start to see how it was applied. Then it became interesting and easier to learn. So if you want to learn code, you got to find a project or something to do. That's just the best way to motivate yourself. All right, so that part works. So now we need to adapt this to use all three of the MIDI positions because it's going to have 3 sliders. Right now we're just checking channel 19. But we have 19, 11, and 1. So I guess this whole thing should probably be in its own function. Yep, it should be in its own function. Oh, upstairs neighbors have decided to run around again. Much better with animals and plants. Hey, but so part of the point of this channel was like, I wanted people to be able to, like, I wanted to do crowdsourced engineering stuff. And the point of that is, or the cool part about that is that everybody knows a little bit about something. So, for example, like Wikipedia is the most accurate encyclopedia in the world, surprising as it is. But that's because thousands of people are editing it, and everybody's contributing the little bit of knowledge that they have. Nobody is an expert at everything, but everybody is an expert at a very small subject area. So, by doing this way, by doing a crowdsource system, I can play off the fact that while I just know a little bit about like embedded devices and the basics of electronics and coding and low level software, there's all kinds of other people out there who are experts in different areas, and I can do projects better than I would have created them myself by getting their help. You're part of your school's engineering program. What do you do there? Like when you say you're a part, what part of your school's engineering program? Let's see. Okay. Generic type course. Interesting. Roof trusses and bridges. Okay. That's so like physics of non-moving structures. I think I took a class on that at one point in time, and I think that's called statics. That specific subject area. Ah. Oh, and moving. Okay. So statics is like physics and structures that are not moving. I don't know what it's called if you're in moving structures. Okay, that's cool. So you can figure out like how like your ratios and everything of the pulleys and all that. All right, I think this will all work right here, and then I can just call this function here. Man, the upstairs neighbor, I think they have a 2-year-old, and they run around all the time. And it's just, you can just hear the footsteps. It just sounds like a stampede. It's really funny. Okay, let's see. Check. Channel 19. Yeah, so I'm assuming that type of math, like stuff that, yeah, 2-year-olds do that. Yeah, they do. That kind of math is like, I had a very hard time with theoretical math, like proofs and, big theories and formulas and theorems and all that crazy stuff like that. But math that you could apply, math that was very easy to see, like, okay, this is how this is used in real life. I was really good at that all the time. I can remember stuff a lot better when I know how to apply it. My sister learned to walk and then never stopped running. Yeah, they do that. They have a lot of energy at that age. All right, so we want to do all these channels. 11. And channel 1. All right, let me make sure that this still works. Okay, looks like it compiled. Let's upload. So we should see our numbers print to the screen here. Yep. Oh, man. You know what? I just realized that this is kind of a waste because it's actually sending the same number multiple times in a row, 59, 59, 59, 59. And we really don't want that because we'll clog up the bus with redundant data. So I need to change how this works down here. Because there's no point in like, so the program he uses is called Logic Pro X, I think. It's Logic something. And we don't want to waste the program's time by sending it the same thing over and over again. Because once it knows that the volume went to 59, well, there's no reason to keep telling it that it stayed there. I think we do need to edit our function. So what are we doing here? So value slider increment log read. What's that value? Slider increment 0.25. I think we might be able to simplify what we're doing here. I think this value is where we need to cast. So the thing we're doing down here where we cast to an int and then divide by 2, we need to just do that up here. Oops. Make sure we get all our parentheses right. Okay. And then we just check if it equals the last value. U does not equal last value. So if the value has changed, then we go in here. And then that's still good. We take this out because we don't need this comparison anymore. It's redundant. And I don't think this is necessary either, honestly. All right, and then we'll format this back. Oops. Okay. I think that could work. And we'll keep our moving average thing going here. Because that updates every time. It does. Okay. Temporary slide value. Let's see if this works. I'm curious. That does change quite a bit, but I might be able to get away with it here. It's taking a while to compile. Okay, there it goes. I'm not totally sure how this moving average thing is going to handle this. So, all right, turn on. Yeah, it doesn't like that. I did something wrong. It's stuck between 0 and 5, and I don't know why that is. All right, I like fun problems. New weight, value divided by 2. Maybe we don't. Maybe this does need to be a float value. Yeah, maybe it does. Okay. Well, this is how it goes. I appreciate everyone's patience while I figure this stuff out. Okay, so we created a function, an extra last sent value. And then we want to take this one. equals, and then we'll cast this. And divide by 2. All right, and then both of these. Oh, and we divided by 2 here as well. Okay, so that was already a problem. So I've already identified one thing, but I'm already committed to this change. So let's see. All right, I think that last cent value. And then we need to set this up here. All right, so by isolating this variable and not using it, we're only using it down here later as to store, to create this value, this one doesn't get changed. And then our moving average function here, which is the new weight times the current value plus the old weight times the old value, is much more accurate. So theoretically that works. And then I think up here I need to change both of these to be ints. And that means this will need a cast as well. All right, let's try that. All right, and we'll upload it. Oh no. Why is it still printing that out? That out that way. It should be an integer. Oh, because I'm using the wrong value here. All right, compile that again. Upload it. There we go. So you can see here that it only sends the number every time it changes. That's better. There's still a little bit of, like, you can see 59, 58, 59, 50, like it's still bouncing a little bit as it moves. But that's kind of difficult to get rid of. It does at least stop though. And doesn't send the same value multiple times in a row. I feel like I could possibly get it between two values. And then make it like, I guess not. Okay. As annoying as that is, it would actually work fairly well. I wonder if there's a way I can debounce. I wonder if I like used our tolerance here. So we set up this slider minimum variance. Let's do slider increment. That seems like a good one. This is where I want it to be. Hey, I gotta think through this. This is getting complicated. Let's see. I don't want it to change unless it changes by a lot. But how to do that? Let's see here. Oh, wow. I had something hiccup a little while ago. I just realized my stream cut out a bunch recently. Apologies for that. Looks good now, though. I think. The FPS is still pretty low. Okay, let's see. No, that's not the right value to use there. Let's use this one, set minimum variance. So basically we want to check if we don't want to like update unless it's changed by a lot in a certain direction. That's where that flutter is coming from here. So when we change the value, we see that even though it doesn't send the same value 2 times in a row, it sends 2 values alternating until it stops, until I stop touching it. And we really don't want to do that because it means that it's bouncing a lot. So we want to clean that up somehow. So I need to figure out a way once to recognize that it's actually physically being changed and not just like a little bit of shutter from it being moved, but actually like an intentional change. Let's see here. I think if I check above here, if this temp slide value let's see if this minus this, so the new value minus the old value. What's up, Bitamy? We're trying to clean up your slide switches because they're being finicky. For everybody else here, this guy, Bitamy, is the one we're doing the project for. You should definitely check out his YouTube channel if you get a chance. He draws, he makes compositions for other people's artwork, for like character art and stuff, and he's pretty good at it, so. All right, slide value, CC19 value. So if that is greater than our minimum variance, then I think we still need to update the moving average. Let's make a new variable. We're gonna have so much like stuff here. Successes were how quick this circuit went together, actually. It's I got it here. The buttons and the switch basically plugged in. I didn't really have to do a whole lot to get it working. I did have to add a resistor, but that's not bad. The challenge right now is this problem. So when I move the slide switch, you can see the new values update here. So if I move up, the value goes up all the way up to 127. If I move down, it goes all the way down to 0, which is what a MIDI actually does. It sends a value between 0 and 127 for a volume. But as you can see, when I go down to the bottom, it goes 3, 2, 1, 2, 1, 0, 1, 0, 1, 0, and then finally settles at 0. So as it goes, there's kind of a shudder, which is really imperceptible to the human fingers. Like, you can't feel that shudder, but within the electronics, that's happening. And so we're trying to clean that up. We're trying to figure out a formula that will allow it to recognize that it's really going down to 0 and to stop and to not change it back up to 1 if that your intent is to go down to 0. That was a bad way of wording that. We're trying to figure out a mathematical formula to smooth out the noise. And so what I'm doing is this moving average sort of thing, which has worked fairly well. It was way worse earlier, but we're still trying to make it just a little better because I think it can be better. I think as is, it would work fairly well with your software, but let's see. So I'm thinking, okay, yeah, so I said I was going to make a variable changing equals false. And then down here, so if this value is a significant amount greater than that value, then we'll say changing equals true. And then we'll only do our update. No. Yeah, if changing, we will update our moving average. And then we also need to go, and we need to, so this is the minimum variance which it can change. We need to set a maximum where it shouldn't change. Else if let's call it max. This is going to get really hard to like tune if we have too many of these in here, so I do need to be careful. If anybody has any ideas, by the way, or you find something on Google that's interesting, absolutely let me know. So once we're within 0.1, we could probably assume that we're good. And in that scenario, we would set this to be false. Now we're basically doing some fuzzy logic here. Okay, so what this is doing is recognizes that our change is greater than a certain threshold. So now we're going to start changing. And if we're changing, then we're going to start updating our moving average. And then if that once that change comes back down below another threshold, which is much lower, so we have to get above like this top value to start changing, but we don't stop changing until we're back below this lower value. So it allows it to move quite a distance there. Once we reach that point, then we can then we stop changing, and then we don't update our moving average until it goes back up above that first value. Anything in between there, we just keep our current state. And then I don't think this is needed, this random Okay, so let me compile this. Oh, elif is Python. In C, it's else if. I get my Python and C mixed up a lot. Changing was not declared in the scope. CC19 changing. My bad. Okay. So that compiled. Now let's upload. And check this out. It's not really any different. Rats. That means the changes are significant. Oh, look, there, I got it stuck in between two values too. Oh, that'd be kind of bad. All right. Well, okay, it works better during big, like, important movements, but slow movements still mess it up. What if I update this value? What if I change that threshold? What if I make this like 0.5 and this like 0.25? Theoretically, that would make it move slower. Okay. Oh, it's better. Ish. It has a harder time near the top end. But it is better. It's a little better. There's less repeated values, but it's still happening. All right. Let's really up this. 1 and 0.5. Let's do 1.0 just to emphasize that it's a float value. All right, we can get there. I can feel this. We can get there. Oh, I got to upload it. Okay. Every time it's a little better, but it's still not perfect. I guess I got to decide what perfect is. Because it is definitely a lot better. Let me change this to like 0.75 maybe. Okay. If we don't get it here, I don't know that we're going to be able to get much closer. That's looking really good, actually. Yeah, there we go. Not a lot of repeated values. Look at that. All right, cool. It just moves up and down to where we want it to be. I hope I didn't just like accidentally use somebody's patented software algorithm by inventing it myself. All right, it looks good. So as you can see, it's moving around here, and we're seeing that we're not repeating the values as much anymore. It's just as I move up, it goes up. So going up, and then as I move down, it goes down. So it's got a nice clean movement on that. Perfect. But I mean, you might get a good mixer yet. All right, and then I think our button still works. If I push the button here, yeah, stop, push, stop, released. I have it plugged into the stop thing right now. Okay, cool. I think we figured it out. I think we figured out a way to smooth out the potentiometer. a way that actually looks good. Okay, so now I need to just make this exact same function for, wow, this is actually quite a lot of math in here too. A lot more than I expected it was going to be. Let's see. Let me update these comments so I understand what's going on here a little better. Update. If nobody has seen an algorithm like this before, we're going to call this the Richardson debounce. The Nick debounce. I'll name it after myself. All right. Convert to int. Send value if changed. Okay. We had quite a lot of globals to make that work, and we're going to have to do that for all of them, which is kind of annoying, but I think it's okay. So we started off channel 19, so let's do a channel 11. And then channel 1. All right, excellent. Now, all right, now we got to basically just copy this function and then change all the number to be 19 or 11 or 1, depending on what it is. We already have our interrupt routines working for the buttons, so. Okay, so that's 19. And then do I got to do it again? No, wait, this is 11. All right, check channel 19 slider, 11 slider, and then 1. Check channel 1 slider. And that should be all of them, right? Yep, okay. So 19's good. Now we need to do 11. Update it. And anywhere it says 19. How's everybody's Tuesday been? So Terrence mentioned this at the beginning of the stream. We saw the SpaceX rocket. Well, we didn't really see the SpaceX rocket. We learned that the SpaceX rocket exploded this morning in a spectacular rain of shrapnel. Unlike the others, this one didn't even make it to the ground. It just exploded. Excuse me. Due to what I'm assuming was the termination system. Okay. Channel 1. I think that looks good. I need to... This is going to be really hard to debug if I miss one. But yeah, they blew up their rocket this morning. And it was... What we could see was interesting, so... Alright, so check channel 11. And then channel 1. Okay. And then I think that's good. Don't have any setup for the sliders there. Now let's upload. And fire it up to see what we get here. We should still see the same channel move. There it goes. All right, so our first slider. Oh, you know what? To debug this, I'm going to need to change this. Hold up. CC19 is, and then for 11 we need to do CC11 is, and then finally for the last one, CC1. Excellent. All right, compile it again. And open our serial monitor. There we go. And turns out if you compile, you should probably upload to the device. Or it won't change. There we go. There it is. All right, CC19 is working. Okay, cool. So let me open. I didn't even open this last time, or earlier today, but I need to open the circuit and we'll get a start and see. I don't remember what pin everything plugs into. Although I guess I could probably just go look here. It's probably at the top here. 2, 3, 4, 14, 15, or 16. So 14 is the lowest one, so I assume I just move up one. Okay, so now 15 is plugged in. So now we see CC11 is showing up. I only have one switch wired up, so I have to plug them. I have to move it between the pins. Okay, yeah. 11 looks good. And then 1 should be the next pin. Move this back down to 0. All right, and then we see 1. There it is. Works great. Cool. Oh no, I managed to get it stuck. Trying not to. It looks like it is possible to get stuck between two numbers occasionally, but it happens seems kind of rare. Wow, I butchered that. Occasionally I get it stuck between two numbers, but it seems kind of rare that that happens. So I'm not too worried about it. And then here, let me open my design. I'll put this in frame here in just a second. Hang on, program's loading. But cool. So this works, and then we know also that all our button positions kind of work too. So I push the button now. You see play is push and release, and I move the wire to the stop, I think that is. Yep, stop, push and released. Then move it to the next one, which I think is record. And then finally function. So you have all 4 button positions working as well, and they seem to be debounced very well also. And yep, that matches up with what I got here. So here's our schematic. switch 1 goes into 2, switch 2 goes in 3, so on, and then on the other side, channel 19 goes into pin 14, pin 15, pin 16. Okay. I think we're good to go there. And our debounces look good, so now we need to figure out how to actually send them as MIDI commands and not just as this serial data. Okay, so earlier when I was playing around with this and looking at stuff online, I noticed this. If you go to USB type, it's set as serial right now. You can actually set it as MIDI, and then you can send things as a MIDI format. So actually, it actually has a lot of built-in like normal types here. So we're just going to select MIDI, and then I think I pulled up something here on how to do this. Okay. So let's see. So I need to send, okay, so for each one of these I need to send a movement. So basically, when you send something, it's USB MIDI dot, yep, okay, that's the correct thing. And then there's a bunch of different options here. We can just do like send note on, and then the first argument is the note, the second argument is the velocity, and the last argument is the channel. So that's just an example of it right there. And if I compile, it's on CC19, so I need to move this back. All right, I just had a heart attack there for a second. I thought I hadn't clicked record this whole time. Okay. All right, so that should compile. Let's just check it real quick. Yep, upload. Okay. And then we'll move this around here, and you'll see that nothing's coming through. Like, it's not saying anything about notes or whatever, or sending anything other than it normally does. So I don't actually have a way to test that thing that says USB send note on is actually working properly. I think what I probably need to do is download either some music software and then try and connect it, or just do something else. I'm not sure. I'm not sure if the serial begin is messing it up or what's going on. But what I can do is do some research into how exactly this works and go from there. Because we need to figure out what so there's no actual thing that says like send volume up or send volume change or something like that. So I need to figure out how to actually send a volume change. This is going to take some reading. I'm just reading through random stuff online to figure it out right now. Okay, I think it's a control change is what it's called. Okay, so a control change over the channel. This is going to be fun to try and figure out. All right, let me go back to this here. I need to update our current goal. Because we changed what we're doing here. Convert or add USB Midi commands. And that period's going to bother me, so I'm going to take that off. Okay. So I start with that. Looks good. And then back to this. I need to figure out. So there's a function called send control change. And we're pretty much hard coded into certain channels. So I got to figure out exactly what the control value is. I'm looking through the reference stuff. I clicked the read the documentation button on Arduino and it took me to the repository, but this is what I'm looking at. If I click read the documentation, it just takes me to the library here. What examples do they have? Control, what does this do? 4 potentiometers, 2 push buttons. I want to see this, because I'm sure this has it in here. Roll onto a 7F. Yep, that's exactly what we need right there. Is this function right here. So what this is doing is sending the control change for the channel. And with, yeah, so channel. And then sending the, what I assume is the control and volume maybe? Okay, yeah, so the second one is a volume command. And then the last value is the actual volume. Okay, interesting. So I can just do basically this here. Interesting that it just, yeah, picks to choose, or just picks to write a byte. I think I'm effectively doing the same thing. So here I'm doing send control change and then 3 values, which are the control, the value, and the channel. So those 3 things that it wanted to do. So for the control, I need to know where he gets these values from. 0, okay. Oh, what's channel 19 though? That can't be right. Because I can only have up to 16 different channels because I've only got 4 bits for it. How do you do 19? All right, we'll come back to that because I don't actually know the answer to that question. All right, we need our our volume, which I think is 1. And then finally, this value all right, I think that gets us started here. Let me just compile this and see if that works. Yep. Man, I really need to figure out... Okay, I'll try and do that for next time. I'll try and figure out a program. Yeah, it's still doing whatever. I'll try and figure out a program to see this happen. And then I got to figure out this part. All right, so let me go ahead and add some defines. Channel constants. F. All right, and then we're going to do that for all of them. So 11 is B. And then one is just 1. Let's see, volume. And then finally, volume value mask. All right, this way I can edit them later. Otherwise, this would be really annoying to try and change. All right. Volume. And then finally, volume value mask. All right, does this compile? It does. I don't think there's any point running it because we still can't check it. And then this example I'm looking at doesn't give a whole lot of info. Two. Oh, is there a function? Oh, I might have gotten that wrong. I think this control is always 0, and that second thing. Okay, hold on. Oh, it's all good. Progress is getting there. I'll show you this part. I managed to clean it up, so I'm not getting repeated values anymore. So 51, 52, 53, 54, 55, 56. We're good to go. And then so on and so forth. So now I'm trying to figure out how to actually send the data in a format expected like a MIDI controller. There's a ton of like sound mixers you can buy online and just plug into your computer through a USB. And there's a certain way that they send data to the computer, and that's what I'm trying to figure out. And this is apparently a really complicated problem because it's just hard to find, because without understanding it, it's hard to find a good example of how it works. I'm probably just not asking the right question, though, into Google. Okay. So what was I looking for here? We probably need to change this. CC19 volume. C1 volume. So that's 1. I think 11 is B. What's 19? 15 is F. And then you start over again. So 16 is 1 0. 17 is 1 1. 18 is 1 2. 19 is 1 3. Hexadecimal is hard. All right, and then volume control change, and we make this B0. All right, let's line this up so that it's formatted a little better. Okay, so then in each function we need to send USB MIDI, volume control change, and then we need to send the volume for the channel. And then finally send this ANDed with our mask. Okay, I think that works. And then we do that for all of them. Uh, 11. And then finally we do it down here on the last one for 1. Oh wait, that's 11. I need to do 1. Okay. Let's see. How's this doing? Just checking my stream health. Let me know if it sounds good, if everything sounds all right out there. Okay. So what's next? I guess we got to do the buttons too, because those are going to be harder anyway. I assume that's kind of a control change as well, of sorts. Just looking through some examples here. What else is there? Okay, so it looks like I'm doing, okay, yeah. So it looks like I am sending this back to the USB correctly. All right. So how to send play and stop and all that. I think there's like certain values you have to send, which are defined somewhere, but I don't know where. I think I could find. Let's see, I can probably find info on this. I don't know if I can show it on stream because I need to, I just don't know what the rights are on this. Okay. Apologize if it's boring. I'm just trying to read and figure this out. This is probably safe to show here, although it's really small, so. C0 to CI for the low levels of the MIDI channel. When data byte follows the status, it is the program number to change to a number from 0 to 127. That's a program change. Don't know if I want that. Controller. Node on, node off. There's our pitch wheel. Interesting. They'd number the notes 0 to 127, where middle C is note 60. Interesting. Second data byte is the velocity. Okay, so this is some useful knowledge, but doesn't have the thing that I need. Let's see. Machine control. I think that's what it was. Maybe. All right, there's a lot. It looks like there's, I don't know if these commands are supported in the existing USB MIDI library. Or maybe it is. Hold up. Clicking through links here. Just poking around more libraries. Hard to find info. Most of MIDI stuff seems to be about like receiving through an actual like MIDI interface or using the device as like a keyboard or something, like a piano. And I'm actually trying to use it to control things like with play, stop, record, and volume. The volume seemed to be fairly easy to figure out. But MIDI machine control commands. The stop command. Oh, interesting. Okay, I found a document here that explains a little bit. I probably can't show it on stream just because I don't want to get copyright issue, but all right, how to do this. So stop. It looks like I might just have to send like a specific byte. Man, I really need like, there's not a good explanation for this anywhere. Okay, I'm going to take this down because I don't think we need that. So it looks like for sending the stop. Nope. Nope. USB MIDI. Nope. Nope. What was it? There it is. USB MIDI. And then our specific, we got to be able to like write something, just like send data or something. I mean, where is this at? Interesting. Okay. So what is the message? I guess just send real time. USB Midi stop. You know what I'm going to try here? I want to see what the value of some of these are. So there's one called stop. I want to push the button and see what comes out, happens from that. Oh, that's function. I need to move this. Nope, that's play. This one's stop. Nothing. It didn't seem to do anything. Is it the right command? One of these prints like an integer, basically. All right, I can figure this out. That seems to be printing the text. I've added another new line here. All right, let's try this. X. I think that'll work. Oh, it needs to be print. All right. So that should print out whatever this value of USB MIDI.stop, because I think it's a enumerated value or something. And I can check if it's the same as the thing that in this document I'm reading here. FC. Okay. That's correct. That is stop. Okay. So that's closer. And what that means is that our command is this is USB MIDI.send real time. And stop. Well, capitalized. Stop. So that's how we send the stop command with the USB MIDI library, supposedly. I wish I knew what all the types were. I don't get a lot of good examples in this library, though. What else do we got? Anybody have any ideas? I don't see. I'm trying to read through the source library for this, but it's actually incredibly unhelpful. Oh, I was clicking through the wrong thing. Hold on. Oh, there is a generic send function as well. That's kind of cool. Okay, so what is play? So stop is FC, play is F2, supposedly. Okay, that's called, it's named something different here, but I think we can make this work. I think we can use it. USB Midi dot send real time USB Midi, and then it's called song position. That is effectively the play command. I think. All right, record's a little different. Because it's a string of bytes. It's a control change. I might have to use the generic send function for this one, though. There's a generic send function that lets you just, like, send a bunch of stuff. This gives me, so, file examples. It's telling me to go look at an example here. USB Midi, but there is nothing called USB Midi. Uh-oh. Oh, here it is. Oh. Okay, well, let me pull this up. This is interface stuff. I don't know how helpful that is, but there is some examples here, so we might be able to make use of this. Teensy, USB MIDI. Just everything. Let's do analog control change, just check that we were doing something correct earlier. Oh, channel. Where's channel defined at? Channel equals 1. All right, is this the same way as I did mine? No, it's not. It's in a different order. Really? Huh. How's it going, Beth? We're just trying to figure out how to do all this stuff. Let's see. Wow, this is actually like, it's so hard to find info. Enjoyed a beautiful day before the rain. Yeah, it is nice outside today. I really appreciate that. Weather's been a lot better lately. So the actual volume is this value, the second value. So that should be that. And then this might stay the same. And then the last thing is, oh shoot. No, I think that works. I think that is correct because that's the channel it's supposed to be on. I gotta scroll up here and look. All right, I think that is correct. That is the correct-ish way to do that. It's not good documentation on these functions, which is really annoying. All right, where did I just change that at? Here. So I need to change it up here as well. Okay, that's 11 and then 19. All right, there we go. Supposedly that's correct. What did I miss? Oh. Don't forget your semicolons. All right, and then upload this real quick, and then just double check that our potentiometer is still working. Go to our serial monitor here, and yet we can see it move as I move up. All right, down, stop, up, stop, down, stop. All right, cool. Looking good. So now back to this, how to figure out, I just don't understand a lot about how this protocol works. Let's see, buttons. Nope, those are just notes. I just keep checking my example. There's a bunch of examples in here, but none of them are using the thing that I need, which is what's making this hard. Input functions basic, maybe. Control change. Oh, that is basic. Examples, teensy, MIDI. How about complete? Handle continue, handle start, stop, song position. I need to do record, which is its own thing. Handle control change. It's the only place it shows up. Where does this value show up at? So control change, channel, control byte. So this is where it's actually just using the serial stuff to actually just do this. Interesting. That explains why we can still use serial print even while it's in MIDI mode. It's because the MIDI actually does just use this. There's still a lot I'm not understanding here. I don't think that helps us. One of these examples should, right? Eventually. Drums. Let's transmit everything. I'm assuming that's just a buffer to transmit everything. Oh, it's actually it's testing everything out. Oh, this send real time thing actually has an option for two arguments. What is the second argument? Cable. Huh. Oh, excuse me. Just trying to stay focused here. I really just don't understand what I don't know, and that's what's really messing with me here. Let's see. Okay, well, I think I just basically need to send... So I found one document which tells me what the record function possibly is. Hang on. It's telling me to send 77. Is that 119? We need a programming calculator. Oh, sorry. Yeah, 119. Okay. So to send record is a control change. B0777F1. Okay, I think I can do that. And I guess I just need to use the send real time command over and over again. So where is that? Here it is. USB Midi send real time. And where's the record? Here it is. And then I got to send 4 values. So the control change, the record. I don't know what all this stuff is though. F. That might work. I don't know that it will. I don't think that it will, but it could. And then I have one more button, which I don't know how to do a button that can be mapped to something else. There's probably like a series of values that are reserved for just whatever you want, but I don't understand how to make that work. All right, a lot more to learn here. I think more than anything, I'm gonna need I'm gonna need some sort of software where I can test this. I guess I got to figure out what that is at some point. Man. Eventually, I'm going to stumble across the right thing or ask the right question and be able to figure this out. But right now, it's just... Oh, here we go. Found another interesting document. 43 pages of just random stuff. I probably definitely can't show this on screen, but it's basically the... this looks like the standard, actually, for MIDI stuff. I might have to read through this in my off time. But I bet this has most of what I need in it. if it has examples. All right, I know this is really boring because I'm not showing any of it on screen. I'm just more or less rambling to myself, and I apologize for that. It's I don't actually know that I can show this though on the stream for copyright reasons. So what I need to figure out, this looks like a pretty detailed document on what exactly should be sent for different things. But I'm gonna have to, it's like 43 pages long, so I'm gonna have to read through a lot of it before I can understand exactly what's going on. So I guess I gotta decide what to do next. I guess I'm gonna look up as well. So we have a pretty good thing here so far that might possibly work in some ways. Oh, excuse me. I don't know for sure that it will, because there's a lot of stuff that's untested. So I think the primary thing that I need to figure out next is I need to download a program and set something up to just like write a quick little simple song in it or something so that I can play it and adjust volumes and things. So I'll have to figure out what that program is. And then from there, we can start debugging and seeing that this actually works. And we can just tinker around with it until we get it to do the thing that we need it to. So if I push the play button, it plays. If I push the stop button, it stops. If I push record, it records. You know, so on and so forth. Adjust the volumes, and certain volumes of different things adjusts. So I think that's what I'm going to focus on doing next, which means that I'm going to basically have to do that outside the stream because I can't download a program while I'm streaming. My internet just won't allow it. And then that'll give me some time to read through this document and possibly figure out how this is supposed to work exactly. Interesting. Let's see. All right. Yeah, a lot of interesting stuff to go through here, but it's going to take some time to do so. Okay. Well, I'll figure that out. Go from there. And then, yeah. Once that's done, so I have my circuit program here, and we can go look at the actual like layout. So once we've proven that it can work, then we're on a good track. Then I'll be able to lay out the circuit board. Hang on, waiting for it to load. Here it is. This is the 3D view. Let's look at 2D. Oh yeah, it's up against the edge. So these are the potentiometers, and then we have buttons on there as well. And then if I go to 3D view, you can see we've kind of put in some parts to spec out exactly what this is going to look like. This will allow us to simulate all that and generate a 3D model of it to put into our final device. Excuse me. And then I just realized that I put a resistor on these buttons on the ground side, and I haven't done that here yet, so I think I'm going to go ahead and do that actually. Because we had resistors in here at one point, and I actually need them here. So since we have time and I can't work anymore on the code, I'm actually going to do that right now. So let me update our thing over here. So our current goal. And we'll just say update schematic. All right, so I need to add a very small resistor on the ground side of each of these. And what that does is basically prevent a short in case we do something wrong on the input pins or something. It'll keep us from just shorting one of the pins to ground and causing a big issue. Oh, come on. It might be freezing up. Hang on. Just let me move it. There we go. Slide that over. And then slide this over. And I guess all of those are not going to slide over like that. And so let's just go ahead and delete that. And then I need to place a part. I gotta remember how to do all this again. It's probably gonna be in my favorites. It is not. Interesting. Here it is. This is the part I was using. All right, I'm gonna need a few of these. Okay, and then properties. And we should be able to hide the part number. Here it is. Okay. Do the same thing here. This is not the actual part number we're going to use. I already have a part picked out. Whoops. That's my stream info stuff. Keep that out of the way. I need to open up the bill of materials so that we can update that with whatever positions we pick here. All right, so for the resistors, R1, R2, R3, and then we need to do R4, R5, R6, and R7. And then draw wires between all this stuff. And then we need to wire to ground. Alright, I updated the BOM as well, the bill of materials, so that's good to go. This is good here, and then we need to compile this. And then update the PCB. So nothing popped up, so that means we probably didn't get any issues. Let's go over here, go back to 2D view. And then import changes. Oh, wow, that was a lot just for that. Execute changes. All done. Close. Look, we have our resistors. And they're looking good. Yep, looks like that's all correct. So we'll have to get them to fit on there somehow. All right, excellent. So let me save that. I'll just go to File, Save Project. So it looks like we're good there. Okay. So I think that's all good to go. I think this is a great stopping place for tonight. So I appreciate your patience and time. There's still a little bit more to do here, and this MIDI control thing is really confusing, but we got a plan to figure it out. So I'll download some software to test it, and then from there it should be easier to debug. And hopefully we can figure out a way to see exactly what's being sent and if it's working or not over the USB. So, all right. Well, I thank you all for your participation tonight and just chatting with me while I worked on this. Yeah, I don't really have much else other than we'll keep working on this. I'm hoping, I really think we're getting close, because once we prove that the software works, then we can start just laying out the PCB and preparing to put it in an enclosure and designing the whole actual device. And I'm really excited to do that part. And then once we have that, we can, once we have it in-house, we can build it and then fine-tune the software. And then I think we're good to go. So, yeah. Should be good. All right, I will see you all later. Bye.